federal states. So in Poland, for example, or in any country in Europe, we have to adapt their conventions in order to make them set them in force in local law state. Of course, this is not easy because the International Maritime Organization cannot say this must be like this and we will do like that, because they are just UN agenda. And as we know, the United Nations are pretty weak in this, so they can only find some mandates, the states, the countries, and during the meetings that they can force some law regulations. For example, the largest, most important convention, like SOLAS, so International Convention of Safety of Life at Sea, that was introduced after the largest accidents like Titanic or other accidents, and then afterwards they said that we need some convention that will care of the life at sea. But this convention is really huge, so also many factors related with the environment are addressed there, not directly, but in some way. Another convention from IMO is that strictly that it's directed actually for the pollution and the prevention is MARPOL Convention, with several changes and amendments. So this is Convention of the Prevention of Pollution from Ships, any pollution. So it's not only air pollution, but also other codes must be also addressed, like IGC codes, so for the gas carriers and the different type of bunkers, also as a gas bunker, or IGF, so the International Gas Fuel Convention, where the vessels are fueled with gas. Not only IMO is giving the regulations, but we also got some local state regulations. Every country has its own Coast Guard. Here, the most intense action actually is done by the United States Coast Guard and relevant coast guards in the countries. We got some organizations like OCIMF, so International Marine Forum for the oil companies, SGMF or SICTO, so they deal with the gas tankers and the gas fueled vessels as well. We got some other conventions provided by the IMO, so like STCW, so the Convention of Training, Certification and Watchkeeping, Load Line Convention, so the convention regarding the design of the vessels and ships, and COLREC, which is most interesting for the navigators, of course, the Convention of Prevention of Collision. This is not directly in our topic, but also must be taken care here as well. So all of these things are mandatory, I would say. So if you are a company and you would like to deal with the international shipping, you have to follow these and many more other law regulations. Okay, and this was maybe less interesting, so we will go into another point. So we got our vessels. So we all know that vessel is interesting only when it moves. So floating objects, of course, are interesting maybe for some parties, but we are dealing with transport. We are dealing with moving of the vessel and for any purpose. So recreational, scientific, transportation, and other. So how does the vessel move? We got first assumption. So we have to drive the vessel with the using of fuel of kind of diesel or gas. The possibility of here are pretty complex. So we got typical division for the heavy fuel oil. So we got heavy fuel oil. This is most typical now propellant for the any floating craft. We can combine this with gas and heavy fuel oil, so the gas can be combined into the existing vessels actually. And the other thing is to combination the gas with the marine diesel oil. So this is the bit lighter fraction than the heavy fuel oil, and this can be down here. The other option is marine gas oil, so we got the even lighter combination. This division here is done for the to see how many different options can be. So we can have a direct drive, so just the power from the shaft is from the engine to the shaft, and from the shaft to the propeller. Then we can have a combination. So we can have a combination with electric and direct with aziput and different typical things. I believe we don't have to discuss everyone. They are more or less the same. I will try to show it in the next part of the presentation. This division has been done by the naval architects, so they are really interested in seeking the possibilities how to deal with the different drives. Okay, so we see that there are three actually types of the propellants. So first of all is a distillate fuel. So this distillate fuel can be accepted in many special areas. So due to its low sulfur content, because the sulfur is one of the most critical, the content of sulfur. Of course, this distillate fuel is far more expensive than the heavy fuel oil, so it must be adapted and must be introduced by some law regulations. It's not like this that the ship owners will say, yeah, it's better, so we will use it. No, we have to force it somehow. And this distillate fuel can be used in this special areas like Baltic Sea or North Sea. The other option, of course, is using liquefied natural gas, LNG. LNG needs a special handling, gives pretty good energy concentration, but must meet many other technical issues to handle it, and of course it meets the plant and current IMO levels of adoption called tiers regarding nitrogen and sulfur oxides. And the third option here is heavy fuel oil, so HFO, with some special treatment. So afterwards, after the combustion, we have the gases emitted to the funnel, but they can only be used in the level that they will be treated in so-called scrubbers and relevant I would say devices, because the scrubber system is just cleaning the fumes from the engine to the before it can be emitted. So NOx level is the same, so it does not affect the NOx level, but it affects the sulfur content. Unfortunately, scrubbers are very expensive in the installation. So these are millions of dollars in the installation, and not every ship owner will do this. And another option is, maybe not option, but another disadvantage is the scrubber waste of the water with some particles, with some residues. It must be treated in the proper manner. Also, Marpol is addressing this, so these wastes from scrubbers must be handled by the port, so they cannot be just stowed away or just left at the sea. They must be handled at the port, and this is the big problem for the ports as well. What we got in air, because the engine is emitting some fumes, so namely we got several different particles that are actually regarded as some triggers to the environment. So first of all, of course, it's carbon monoxide. That is something we cannot avoid when we have a combustion engine, unfortunately. Sulfur dioxide, SO2, nitrogen oxides, different ones, ozone, VOC, so organic compounds, and also the aromatic hydrocarbons here can be emitted as well, and particulate matter. So some solids inside the fume, very small solids, ashes in the exhaust gases. Here we got the HEATCO study. This one is pretty old, but they were also amended in due time. So the health impacts for humans, for every live being, is of course respiratory impact, cardiopulmonary, cerebrovascular, carcinogenic. So all of these, most of these particles are carcinogenic, and inducing asthmatic reactions. So the human health is affected by its own activity. And we are also dealing with the losing of the environment. I would say cleanliness. I believe all of us heard about PM. So this particulate matters, very small solids inside the fumes. There can only be also ions or some reactive gases. Some of them can be even radioactive, actually. Some metals and carbon cores. So these are really nasty things. We deal them with we actually generate them using our facilities, power plants, incinerators, etc. So we generate them in any kind of typical engines. There are two classifications, below 2.5 millimeter and below 10 millimeters. So for us, both are pretty dangerous. So we can say that it's pretty problematic. We know that in the modern diesel engines, in the road vehicles, we deal them on the many aspects. So we got some EGRs, we got some dust collectors, etc. DPF. These are the things that must be addressed also in the shipping. What are the impacts on the environment? Here we got the Californian actually agency that has collected all of the impacts taken from the fossil fuels to the environment. What we do to our environment when we use the engines. I don't think so that we need to go through all of these elements. You can find it. You can find it here. First of all, of course, apart from our health, so we are inhaling this in our bodies. We got global warming from the CO2, and we get the smoke affection, acid rains, global warming again from the nitrogen oxides, and different things that can affect can affect us. What are the sources? Of course, here we got the sources. So of course the carbon itself, the hydrocarbons, content of sulfur, so we can avoid it. The temperature of the combustion is also the level here. Emissions of the gases, the so-called greenhouse gases by sector, and this is pretty constant. I believe that we got this at the same level now. So the billions of tons of emissions came from the energy, as we can see. So we are not the transportation is not the biggest player here. But it's not small actually. We got other sources of the emissions. So here all it's rising because we got the bigger demand for the energy. The transportation is growing, etc., etc. Who is the largest emitter of the greenhouse gases in the maritime transportation? Actually, all depends on the size of the fleet, and we get the fleet of the Panama, so it's the largest player. Liberia and China. So all others are, of course, 65%, but these are the three key players now. Of course, Panama and Liberia are so-called cheap flag states. So they are only having the vessels registered down there, but the owners are, of course, in not residents of Panama or Liberia or Bahamas. They are the residents of Europe. They are the residents of US and other sides of the world. So is it like that Panama is responsible? No, Panama is just the flag. So we have to take care and address this. IMO got a huge problem with these cheap flag states, and after it has been shown that the owners of the vessels are somewhere else. And for comparison, we got our megaships emissions. So this 15 megaships emission. So triple E container, for example, is related to 760 million cars. So it's really huge. But this transportation again. Is large emitter, but actually is still dealing with some spares regarding to the wheel transportation. So it's still more ecologically friendly. CO2 emissions, of course, international shipping is the largest one, and the fishery and the domestic are the smallest. What MARPOL measures are introduced? First of all, is EEDI, so Energy Efficient Design Index for the new ships. And it must be mandatory on the energy efficiency level. But for the existing vessels, because most of the vessels in the international trade are existing vessels, so the old one, they got something called CEMP, so Ship Energy Efficiency Plan. Here, both new and existing ships must comply with this through the operational measures. So also introduce the meteorological routes, so to spare the fuel, optimize the draft and the speed optimization, and of course calling, just entering the port on the proper manner. Also, the efficiency of the transportation, as I already mentioned, through the water is most efficient one. So it's most efficient one because of the high emission from the singular vessel, but the one singular vessel can have thousands of containers inside. So this transport efficiency for the grams of CO2 per tons per kilometer is the best one. The least one is aviation one. It's aviation. Marple action to reduce the carbon intensity, of course, introduced for the new vessels, as we already said, and for the existing one. And this action is to emission the CO2 emission CO2s for the transport operation for average by least at 40% by 2030. For 40% by 2030, this is really, really huge number, and most of the specialists say it might be done, but this is just might. And going to the 70% by 2050 in comparison to 2008. So it's really, really huge number for the environment. If it will be achievable, I have no idea. We will see. Greenhouse gases emission to reduce at least by 50% to the 2050. This is also a really, really big number. What can we do? Of course, we can introduce the cleaner fuels. One of this is natural gas, so it's nearly pure methane that has it produces less nitrogen oxides, sulfur oxides, and PMs. Got less hydrogen and carbon than diesel fuel. So these emissions are also lowered. And the amount of here the amount is also related to the current combustion. And LNG or CNG has a lower price per megajoule, so it's more energy efficient. But the storage is a problem. Storage is a problem for the long distance vessels into international shipping. It can be a big problem. Advantage is, of course, the contamination, because if we got the leak of the heavy fuel into the sea, we know what can happen, like in Exxon Valdez, for example, where Alaska coast was heavily damaged because of this tanker. Here, we got nearly no impact on environment. It's really pure. It's really pure for the water. What are the LNG shipping sector? How big is it? Number of ships, of course, is increasing. We don't count here the LNG carriers, so these are the only vessels that are fueled by the LNG. So they are bunkered with the LNG instead of the heavy fuel oil. So we got only this. So it's rising really fast in offshore service and relevant vessels types. It's rising really fast. So ferries are here a good example, and also other vessels too. What can we expect from LNG? We can expect, especially this PM's reduction of level 90%, greenhouse gases around 25, NOx around 20, and SOx nearly 95%. So it's really clean fuel. Cleaner engines, cheaper maintenance. These are the biggest advantages. Output efficiency, easy storage. Maybe not an issue here, because it's rather it's not that easy to achieve the easy storage actually here, and pretty fast refueling, fast and clean. Another type of the I would say the reduction measure is using biocomponents inside the diesel. So we are not using something that is purely made by the plants, but it's just an addition to the diesel fuel. Of course, the diesel fuel cannot be heavy fuel oil. This must be some kind of both marine gas oil, so very light one, gasoline, or marine diesel oil, so pretty also lighter than the HFO. So we got few methods of additions. So the bio additions, we got fatty acid methyl ester. from the different types of natural oils also can be used here, and this marine diesel has appropriate ISO standard up to 7% in volume. Also, two different methods. So the BTL can be also used for the diesel engines. Different type of processing, and HVO, vegetable oil here also can be treated inside the marine diesel oil. But nothing is for free. We got some disadvantages and some challenges, I would say. So bio additions are more reactive. So in high concentration, they can react with some types of gaskets and different alloys. So the designers have to take care of it. Problems because of these are the natural things. So we can have some microbiological growth and especially different problems here, and degradation of it in due time far faster than the typical diesel oil. Also, corrosion here is another issue we need to address. And the low temperatures. So not every biofuel component can be used in the low temperatures, like Arctic shipping and our areas when it's cold. The end, we got some comparison of the emission per milligram or gram in megajoules. Here it seems that this marine diesel oil with the low sulfur content can achieve the lowest ECA standards for the special zones. Also comparing with the gas oil and typical biodiesels and natural gas. Something that we did not address was LPG, so liquefied propylene gas. So compound of the propane and butane, because it's standard that was not actually very widely introduced. There are some vessels propelled by the LPG, but these are not standard because they do not meet many emission types, and it's not that common. So going into some discussion, we have to look at the LNG fuel. So LNG fuel, is it something that will become the large player? This is the question. It's rising in many sectors, but it's still very low amount of the vessel are propelled by the LNG. LPG, as I said already, standard that was not introduced. Biodiesel is a good idea, and then it adds a lot of advantages to cleaning the environment. It has some issues, but still biodiesel in large engines can be successfully introduced. And problems with the legislative. So at the very beginning of this presentation, I already mentioned this problem. So the international regulations, then the national regulations, and then we got a lot of regulations. But is it really something that we must obey? No, because it's a question. It's a question that, of course, this international regulations must be met, but if there are too many, then of course it's not really wise for us, and it's not really feasible for us to deal with. Okay, so this is the discussion questions from my side, from the presentation side. It's everything, I believe, and we can start the discussions. Maybe some questions.
Thank you, Professor Gutzma. I have a question. As we know, in the public transportation, especially in cities like Amsterdam, for example, and the other cities where the transport is covered by water, on the water by many ships, what kind of drive would you like to suggest for a person who are interested in buying or building that kind of ship? As we know, the pure electric propulsions are the perfect solution, but from the environmental point of view, of course. But as we know, the energy density is not very high. So what kind of fuel from the environmental point of view, the professor, you will suggest for the users, for the organizations, for the city majors? So what is the answer?
Well, it's both easy and pretty complex, because if we say, if we look here at this presentation, we were mainly dealing with the international shipping, so the long range shipping, but also the shorter range shipping, and even the coastal shipping, like the Amsterdam, or going into the river. So now it's pretty complex. We have to first address one thing. So the biggest problem with introducing LNG was where to fuel it. So the first vessels now trading in the world, in the Baltic Sea, here, or in the North Sea, they are somehow fueled from the trucks, from the trucks. So typical truck, diesel truck, is bringing clean fuel to the quay, to the port, and it's fueling the clean vessel. So is it really wise? I would ask. Maybe not, because it will be nicer to see the bunker barge propelled by the LNG than fueling the LNG vessel, small, large, I don't know. And then we can say it's more cleaner. But going with the truck driven by the diesel with the clean fuel for the vessel, it's a question, So it's a question. There are no choices. So if we don't have the power outlet in our port, we cannot charge our electric vessel. So we have to charge it in a different manner. So we need to have some kind of generator that will make this power for us. So I believe the hybrids will be the answer. For the smaller vessels, maybe the hydrogen is the answer. So looking into this scope, we see multitude of different ways. What will be? I have no idea. I'm not that brave to say it will be LNG and electric for sure. Maybe yes, but I believe the awareness is the answer, because if the owners are aware that I don't want to use marine gas oil because it's still inducing some fumes into environment, I would like to see the electric vessels, or combined, so combination. For the smaller crafts, like pleasure boats, recreational crafts, all swinging all around the globe, we see that there are some options, like electrical driven by gas, so this is electric driven, the accus are charged and then they are driven by gas. So maybe it's an option, and the awareness will bring it. So the people will be aware, I want to spare my environment, I want to inhale clean oxygen, clean air, not fumes, particle matters, or SOx. So this is the answer. But really, looking at the recreational crafts, it's a small amount. It's only a small amount, because look at the ferry that is going, for example, inside the big cities like Gdynia, beautiful city of Gdynia. Large ferry is going inside the basin, into the city. How many different things it produces. This is the advantage, not the small craft. Thank you.
Okay, thank you. Does anyone from the audience has possibility to ask the question?
I have a question.
Yes.
So let's assume there are fuel stations everywhere, and I think that people will always choose cheaper option. Therefore, only regulations can make a significant change. And do you agree with that? Or perhaps can you see other possibility, for example, technological advancement, like better engines or something like that?
I agree in 100%. So if you just make the LNG bunkering possibility everywhere, but it will be really expensive, we will not have the breakthrough. We will just stay in the place where we are because every ship owner will see, oh, it's too expensive. Maybe let's try the scrubbers or something else, you know, and then still this heavy fuel oil is there. So the international regulations are getting smarter and smarter because in the beginning they say no, that there will be no traffic inside the ECA zone, for example, using heavy fuel oil. But then the ship owner says, hey, come on, stop. You cannot do like this. There will be no transfer of good, no nothing, you know. And they are getting smarter and smarter, encouraging us to seek for the new challenges, seek for the new sources of this propulsion. Here, this project is a great example. When I look at the outcome of this project, I'm really happy that I can have access to it. So I agree, but then of course you have to encourage these ship owners, every ship owner, not with also with the money. Of course, it cannot be very expensive, but you have to encourage them, saying you will be eco-friendly somehow. And look what happens in the vehicles. You know, in the Netherlands. You know, people are aware. They don't use cars. Also, although they get really nasty weather, most of them are riding by bikes. You know, just to spare the environment to have the cleaner fuel. One of the things, of course.
Okay, thank you.
Thank you. Does anyone has a question?
I have a question. Hello from Stralsund. Thank you for this very nice presentation. And I would like to know, how do you think this can be controlled? I mean, international waters are a big area. And if we think about, for example, LNG or SNG, so LNG being from natural gas and SNG being made methane, liquid methane made from green hydrogen. If it is available in different ports in different qualities and with different regulations, do you see any way that this can be controlled worldwide, or do we just have to rely on other nations being honest? And we saw how that is problematic already with the diesel and the oil and so on. So my question really is, do you see any way to control that in the international waters?
Yes and no. Yes and no. Again, the awareness of the ship owners is the key here. So if they will not be treated like a criminals immediately, so that they will be just the partners for the discussion with the IMO, for example, or the European Maritime Agency. These are the things. These are the key important issues here. So the regulations, of course, must be met, and then the police somehow. International police or the local police. I say police, but it's of course the Coast Guard and many different bodies. They have possibility to check it. But look what's happening in the water pollution. If we see what EMSA is doing now with the water pollution on the special areas like Adriatic or the Baltic Sea, they are trying to track the polluters, and it's not that easy. It's not that easy. Here is the same. Even now we are dealing with some project where we use the drones with special measuring device just to follow the vessel and smell its fumes to see if there are any emissions that are not actually in line with the MARPOL regulations. So. Being honest, of course, I would like to see that all of the ship owners are honest, but this is the money. This is also the money. If we start only dealing with the forcing the regulations, we can skip the point where the ship owner is a partner for us. So this is my question. I don't know.
Yeah, no, thank you for this answer, which is kind of optimistic, right? I mean, we have the technology and we need to control it, and that's right. I mean, if
Yeah,
the ship
exactly.
owners are aware that they are controlled, I think that helps a lot.
Exactly.
So thank you for the questions. I think now we will start the second presentation, and Maciej, please, floor is yours.
Okay, thank you very much. I will just skip to the screen immediately. Okay. Okay. Do we have a visual?
Yes, it's perfect.
Yes.
Okay, very well. So going into the topic, classification of.
Maciej, this is not this presentation. This is third presentation. Second, review of the methods of the gas purification. So it will be.
Yeah, sorry for my too fast clicking.
Yes, it's perfect. Okay, thanks.
Yes. Now it has sense because now it has sense. Okay, the revision of methods used for exhaust gas purification for the internal combustion engines inside the vessels, of course, leisure crafts, etc. Ladies and gentlemen, the same presenter and the same authors, and what we got here is, of course, the problem of emission, definitions of MARPOL solutions. That's why I was not mentioning it too much in the previous presentation. Existing designs, what we got now, and trends for the future will be addressed here as well. As we already saw, the waterborne transport is most efficient per kilogram of transported mass. So it's for sure cleanest for the transported mass. But the problem is the concentration. So the big vessels inside the ports, they are emitting a large volume of substances in the some short amount of time. What was proposed by the IMO is a definition of problem and the action, and the emission standards are referred to tier standards from 1 to 3, and at the end we shall have some cleaner exhaust or changing to the alternative fuels we already got. Not only the fuels for the combustion engines, but also the hydrogen and the pure electric propulsion. So the tier standard number 1 was defined in 1997, and in the annexes 6 to the MARPOL, tier 2, 3 were introduced by the amendment to this annex in the 2008. We got some comparison here. What was the idea? How to deal with it. We already discussed it, so I believe we will not get back to this. But we agree. The signees of the MARPOL Convention, the 50% will be affected, so the less than 50% in next 50 years. So this tier 2, tier 3 annexes were in force from the beginning of 2010, so already 10 years, and also NOx requirements were done here for the older engines. So Ratification of this revised annexes were done by the most of the countries, so something like 80% of fleet, more than 80% of fleet of the whole tonnage, world tonnage. Okay, so what are the emission control areas? I already mentioned this in previous presentation, but the emission control areas are defined in the Annex 6 of MARPOL. So these are the local I would say areas. So the local waters of some parts of the globe, where more stricter requirements are applied to the vessels in case of any emission. So these ICAs are Baltic Sea really early adopted. So one of the first basins. We all know, because we live here, how fragile the Baltic Sea is. So we have to really take care of it, and we have to really share it with our kids, actually, in the unchanged state. So this is the idea. SOX adoption was really early in 1997. 2005 it was enforced, and NOx is entering now. Similarly, it's for the North Sea, also North American, and they do got some ICAs for the US and Canadian coast, and the US Caribbean ICA is of course introduced by the US because it's their territory, Puerto Rico, Virgin Islands. So the ICA for the global mainly for the global concept is mainly greenhouse gases emission, lowering the greenhouse gases emission. And this was another step. So we got this tier allowed that is allowing the NOx emission for different tiers. As we can see, this tier is highest requirement for tier 3 inside the ECA zones, depending on the RPM of the engine. And of course, as we are all mostly engineers, we know that the RPM is related with the temperature. So the temperature of the emission is a crucial here. We got the greenhouse gases regulation on the efficiency for ships. We already also touched it in the previous presentation. And these limits apply for diesel engines with power output of more than 130 kilowatts. So we see that this is not affected to the real small leisure crafts and something like this. This is more for the trade and shipping. But of course, the countries itself can introduce stricter regulations for the shipping and stricter regulations for the leisure craft. So it's going into this way. Is it okay or not? We will discuss it at the end, maybe. So we got this greenhouse gases emission, sulfur content of the fuel for the ECA, or called SECA, so sulfur ECA, SOX emission control. We got two levels, and these are the sulfur content as a percentage inside the fuel, So IMO is trying to set the standard for really low sulfur content inside the zones. How can the sulfur oxides inside the fumes and sulfur inside the fuel can be lowered? First of all, using marine diesel oil. So distillate fuel is far more expensive than the heavy fuel oil. And second is scrubber means. So we also said about the scrubber, so the exhaust gas cleaning system. And the 0.5% is our target. Efficiency, CEMP for all ships. So the plan for the efficiency must be implemented. We discussed them, I believe, a bit as well. So going just EEDI for the new vessels. So the new vessels must comply with EEDI. This design index, we saw it probably in our country when we introduced the similar design efficiency index for our houses. So the new built houses must meet some thermodynamical requirements. Here it's pretty similar. So what we can do from the technical means for the combustion engines, large engines is dealt with the MARPOL, solely MARPOL, and scrubber or conversion to the another fuel. So the conversion to the another fuel. This conversion, of course, requires a lot of changes for the big engines. Converting to LNG is a big challenge. First of all, these are the large engines. Medium engines, when they are around this 130 kilowatts, they can be both affected by the MARPOL or Euro standard. So we got Euro 6 in versions now. For the new engines, and here we might assume that also the typical solutions from the automotive branch will be fine, like EGR, so exhaust return gases, DPF, so the particle, and other cleaning means. For the small engines, only Euro norm is set. The problem, of course, is with the different countries, non-EU countries, since we have our own regulations. We adapt from European Commission. The other countries, no. EGR valve here presented as a mixing valve, so anything that can be found inside the exhaust gases here. I will just show exhaust gases here. They are combined with the intake air to the manifold system known from the diesel engines in cars. From the diesel engines in cars, and of course CC catalytic converter as a purification, the simplest system we can have now also in diesel engines on smaller crafts. What we got for the emissions, we got SOx and particles. SOx and particles are treated by the DPF filter. So this particulate filter that must be cleaned occasionally, like in the cars. Diesel oxidation catalyst. So we get this catalyst. Of course, we are not discussing here the marine gas oil. So I would say that the light fraction of the hydrocarbons here are not taken into account, only diesel oils. And the third one is continuous regeneration trap CRT. For the NOx, we got this SCR, so selective catalytic reduction, pretty complex thing. EGR, of course, is helping with NOx emissions, just to retreating them to the intake manifold. Non-thermical plasma, so another new mean. And lean NOx traps here is fourth option. What were the tiers, the euro tiers or euro levels from beginning from euro 3, 4 and 5? We got this comparison. These arrows indicate the years of the introduction of each technology. So for example, DPF as obligatory means here reduces this level of NOx, for example. I recommend this article. Here is also the link for it. So any you, ladies and gentlemen, interested in the details, this article gives a lot of details in these technologies. For the Euro 6 emissions, we got the following numbers for the petrol, so for smaller engines, and for the diesel, we can assume these numbers here. Okay, going back to our larger vessels, the types of scrubbers here. The picture and the comparison is designed by the gas cleaning system association. So there is association that combines all of the designers and manufacturer of scrubbers. So we got different type of scrubbers. So the exhaust gases in any type are treated through some special tower, so-called tower, here in the most open, the simplest way. So we got open tower with some spray washers inside. So anything that is heavier than the particle of water, it's trapped in it, and in particular goes to the residues and must be stored, as we already said. And the cleaner outlet, not the clean, but the cleaner outlet is directed to the funnel of the vessel. Cyclonic one, more advanced. So we got some kind of separator for the gases and fumes here. Packed bed. So we got special material here that is trying to restrict the movement of these fumes and being trapped by the water again here. Wet bath. So the fumes are directed to the water and then go back to the funnel. And this was pretty, I would say, a lot of promising method, but it's not that easy to build working system. Some washer inlets. So for the smaller funnels, we got some washer, and the exhaust fumes are flowing through the special membranes here. And Venturi, known from the burners, so we got the inlet of water that speeds up the fumes and traps any particle that we want. How does it work in the looking at the vessel? So first of all, we need to have a recirculation valve. So this valve must be open when we want to clean our gases. We got some small pre-scrubber that will catch all of the larger particles than the designed one. It's especially because some of the parts of the carbon they can also travel inside these fumes. Then we got the scrubber itself. So the fumes are scrubbed here, so they are trapped by the water. So it must be driven with water, and then purified fumes they went to cooler, some kind of blower, and they can be set back to the exhaust. So that they travel outside of the vessel via special mixing cooler. Of course, we need the water. We need the tank to buffer the residues. Also, some water treatment. Water treatment is done because the large amount of water cannot be stored inside the vessel for a longer time. There is no place for it, and this treated water, so partially cleaned water, can be either driven out of the vessel to the sea if it meets the cleanliness level, or can be again used to the scrubbing of the fumes. The scrubbing of the fumes. Additionally, some chemicals must be added to lower the content, chemical content of the water. Of course, as you can see, it's really complicated. Typical installation of this system for the bulk carrier of 80,000 tons is something like $5.5 million, $5.5 million, which is really big amount. Proposed solution, of course, is a change, not to going a step back or standing in the same place, just using some purification. But of course, the change we have also got on our discussion. So from diesel to LNG, or to hydrocarbon, or to not to hydrocarbon, to hydrogen. Sorry. From diesel to LNG or hydrogen. These are the possibilities. Using fuel cells or solar cells also for the smaller craft. It's an option as well. Pure electric one, they must be somehow charged. And if we remind very well the first presentation, there was a comparison between the energy production and the transportation. So if we produce clean electrical power, that is really nice. But if we produce this power from the coal or from the gas, etc., it's not pure. It's not pure. The level of the environment impact is the same. So maybe it's a bit harsh, but we have to always think, where does this electricity came from? And the biofuels, as we already discussed, got some advantages. It can be used, but also it's not the best idea. LNG reduction, we already got it. Possibility of retrofitting engines is not cheap. It's not like this, that we will just put the storage with the LNG, set it to the injector, and we will have the retrofitting. Not all engines might be changed. Not every single construction can be changed to LNG. Sometimes these constructions are pretty old, and or they are just not feasible to be changed. What is used here for the driving on the LNG are of course gas engines. So the gas engines, instead of the fuel engines, the typical fuel engines are just directly designed to be used using gas. This is the best solution. Unfortunately, pretty expensive. LNG also can be driven with using steam. So we produce this steam from the heat of LNG, and then we drive the typical turbine. We will show also this solution. Retrofitting of heavy fuel oil, as I said, not every heavy fuel oil can be changed to the LNG. Whilst the MDO, so marine diesel oil, it's more likely can be changed to the LNG. Emission reduction, as we already discussed, is at pretty high level for the LNG driven vessels. LNG sources. So we got storage. We got some storage, some gas station. So must be done locally. Problematic. Many different things must be met to store the LNG in local, in some kind of gas bunker station. Another option is, of course, the bunker barges. Bunker barges, so the small vessel with the LNG inside its tanks can just moor to the vessel, propelled by LNG, and then it can be bunkered, like typical bunker now for the done for the vessels driven by heavy fuel oil. LNG trucks only in ports, so this is done now. So our terminal Świnoujście is exporting hundreds of trucks with LNG, and not only for the vessels, of course, but also for the typical installations, the houses or the facilities. And so this is the missing link. If we didn't have here these trucks driven, of course, by the diesel oil, we would not have the advantage for the LNG propulsion of the vessel, because there will be no facility. Fixed pipe installation only feasible for ferries. The Swedes, the Sweden was the first country that was introducing this. This is not feasible when you don't have the ferry, I would say the tram or the bus going through the sea. And LNG container and special container that can handle the LNG inside for many days. Also new technology, and it's pretty much rising now. Hydrogen. Okay, so we skip from the LNG to the hydrogen. The hydrogen itself requires the diesel forced injection, so the addition of the hydrogen to the diesel. Another option is hydrogen pure or air mixture, and pure hydrogen gas engines. The fuel cells itself is a really promising technology, and this requires the feed of the hydrogen and oxygen we can find in the air. The production due to the through the electrolytes, or some kind of reaction here, gives us water. It's okay for us, so the nearly pure water. And there was even some experiment where one of the guys was drinking water from the outlet of fuel cell. And carbon dioxide. And carbon dioxide is also required for the reaction here. But we got flow of electrons, so electricity is produced. The questions here are, of course, the durability, the safety of storage, performance, and cost, because they are now. Scientists are building the larger and larger these fuel cells. Different technologies are emerging, so it's a open question if it will be something really giving advantage to our propulsions. Solar power, it's a nice until you have power, of course, until you have sun on the moon. Safety of hydrogen storage is not an issue here. Of course, it's a mistake. Sorry, but this photovoltaic reaction is getting more and more. I would say the promising technology. A lot of us has already photovoltaic plants on the roofs of the houses. So it seems to be clean. Of course, there are always some issues with it. So like the production and utilization, for example, here. What are the cell efficiencies? We can see that the big giant leap, I would say, was done from the early beginning of this technology. Now the cell efficiency is rising up to 47% now, so it's really high, I would say. This comparison is also very nice for the students and for the researchers that would like to see the promising technology in this photovoltaic types of generation of power. Pure electricity of the grid, again, nice, clean, looks good. No fumes in the place of using the power. Again, the cost of accus and batteries, the safety of storage is a question. Technology of storage is a question, and where do we take this electricity from? This is the largest question. Again, this graph with the energy production. So it's not that easy to say only electrical and then the world will be saved. It's rather open question, I would say. Biofuel, we already got, I believe, in some point. So adding this methanol to engine is another option. So biofuel and then methanol or esters to the engine is another option. Some reduction is met. But we're still in the same point. So we're still in the point when the internal combustion engine is used. So discussion here is of course the features of the MARPOL requirements, small engines, Euro norm versus MARPOL. LNG, is it the fuel of the future? Maybe no. And the electricity, yes, no. We can see. We prepared some references here, so I encourage you to study it in original. A lot of files, lot of resources can be found on this pages and papers. From my side, it's I believe all in this topic. Now, I think it's a time for the discussion. Thank you very much.
Thank you, Maciej, for your presentation. Because of the agenda, I suggest to only one question, and we have that kind of question on the chat. So I will ask the question. So generally, two questions. Do you think using new technologies for wind using on ships can contribute to reduce the emission? So new technology about the wind. And the second question, what do you think about ammonia as a fuel? Wind and ammonia. What do you think, Professor?
Okay, thank you very much. I see this question now. First of all, the wind, usage of the wind, so typical sails or some kind of parachutes in front of the vessel. These are the ideas. We actually go from there. So we go from the rig vessels with the sails. That was driven by the wind. So then there was, of course, the steam and the coal and some hydrocarbons, etc., etc. Now we are where we are. But the concept of using this wind, so utilizing the wind on modern vessels, it's not new, because if we look even in the 70s, we got some concept of using big rotors on the steamships. Then we got some concept of using large parachutes deployed in front of the vessel. But the force of the wind at open sea, this is something that must be really, it's really underestimated actually. So there can be a large technological problems. But I would not claim it's not promising. It's promising now. Even I saw a couple of days ago, one company introduced this large additional sail for the I guess, LNG-driven vessel or some sort of that kind of vessel. The companies are looking for this solution, and the power of the wind is something that we really underestimate. Even if you look at the leisure crafts, the wind can generate electricity, and many of the ship owners, smaller crafts, they are using some turbines just to generate electricity during the standing. What about the ammonia? Ammonia as a fuel. This was also some kind of concept. Ammonia as an additive to the combustion process. Again, can give some advantages to the lowering the temperature of combustion. But honestly saying, I was not digging enough into the problem. I would have to say ask my colleagues if they are more aware of it. So I cannot say yes, no. As an addition, it was known for some time, but as a pure fuel, I have no idea if there are any significant advantages done now. If there is something to add, I would just love to hear from you if there are some advantages in that manner. So we can share the knowledge. Thank you.
Thank you. Thank you, Maciej. So, because of the agenda, I think we will start the third presentation. And if any additional questions, please ask them on the chat. And I believe that Maciej will answer it after our seminar. So let's start another presentation.
Okay, thank you very much, Mr. Chairman, ladies and gentlemen. Again, me. I'm so sorry. So
Maciej, you are brilliant speaker.
No. Don't say before the end, please. Don't say before the end. Okay, so I would like just to share with my screen, and the question will be same because we now going very well. Do we have a visual? So the third option is a classification of vessels from electric point of view and requirements for safe use of hydrogen fuel cells. Okay, so if we see the presentation, the content will be of course what we got now, the scope of the idea, topologies, examples, safety of these cells is a largest issue here, and some discussion I believe we will have time for at the end. So going from least interesting things, so the certification actually and law implementation. The electric-driven vessels are introduced in few countries in the world. I would love to say that in many countries, but we have to say that only in few, where the most intense actions are done by the Canada and Norway. So these two countries are oldest in the implementation and has the largest experience, I would say. But not only it's not like this. Only two countries are in the lead. Electric driven vessels, purely electric driven vessels is one option. So storing the energy of the electricity inside the batteries. Second one is driving the generators and then propulsion of the vessel using electric motors. What does it give to us? Of course, it gives us the efficiency because the gas-driven generator can work in the most efficient manner in certain speed, and constant speed. If you don't change it, then you don't have the performance loss. And hybrid solution like accus and generators, we will also discuss it here. The size of the vessel is a key factor. Of course, regarding if we discuss the smaller crafts, leisure crafts, ferries, boats, or the really large vessels. Scope. We were considering with my co-authors how to scope this issue, because if you got Marpol, then you have to scope it because Marpol, because we are the signees of the convention, and we got to follow this Marpol. So there is no choice, fortunately. But how to scope the electrical driven? Because many different parties say, yeah, you have to try, seek, and then do it. Mainly, we are here now because of this action, which is really, really brilliant and desired. But what is the scope? But the scope is pretty simple. If you live on the coastal area or at the island, you have to depend on the ferry for the transportation. Yeah. So if you live at the country that has some exchange with another country through the sea, you have to obey. You have to depend on the transportation of the containers, goods, bulk cargoes, etc., etc. This living in this coastal area or the island can be just the triggering action to see if it's possible to lower the pollution from these exhaust fumes and gases inside the port. Even small vessels, but in large amount, like this Amsterdam, you already, Krzysztof, mentioned. It can induce a lot of harmful substances inside the port, and then the living will be just has lower standard, which we don't want. We want to live in clean environment. And conventional ferries, apart from the greenhouse gases and other harmful substances, they are making a lot of noise. The engine itself, the typical combustion engine, is generating a lot of noise, which impacts, of course, wildlife and humans. Norway and Sweden, and partially Poland, already addressed it. I don't know how the other countries, because I was only considering these three. Probably also they addressed it for the standard ferries, just to shutting down the generators inside the port. So they are just connected to the grid, and there is no noise from the generators inside the port, which was a big problem. Okay, who is providing knowledge into this topic? This is EMSA. Fortunately, our EU agency is providing a lot of knowledge. I encourage you to study the materials they provide in the electric driven vessels. You all know about it because you are the Elmar aware companion. You are very aware participants in this valuable project. But again, some things are just showing up really fast. So it's really worth to see what does EMSA have to say. And the second one is DNV. Now it's called only DNV. Before it was DNV in Germanischer Lloyd. Now it's only Det Norske Veritas. DNV also has a lot of things for the electrical driven vessels. Also good source. Classification societies, electrical societies are also important players here. So what can we expect on this EMSA cost benefit matrix? This is really valuable sources I already mentioned. So basis is using the pure electric energy in the way it's done. So what are the savings for the vessel if we switch to the pure electric energy? And EMSA together with DNVGL, they found out how to show the potential of saving the fuel, when it will be the payback for the when the payback will happen for this retrofitting and changing. What are the main consideration for the batteries, and then what are the main factors for the maximization of this impact. Not every vessel can go into 100% saving. Some of them are pretty low amount, I would say. But as again, the ferries are the biggest players here, and the relevant vessels like high-speed ferries and similar are the key beneficial here. But the other vessel as well. So it's not only the ferries. The problem is, of course, with the seagoing vessels. Some kind of the vessels that travel through the ocean. It's really hard to find the electrical plug in the middle of ocean, because then you have to somehow take care of this. So of course this is only pure change to the electrical means. What we deal with the batteries is a balance. So the balance in the power versus energy. Power versus energy. Of course, we all know that it's more or less we can find this energy assumptions rate, and this can be optimized somehow. At my university, we are dealing this for the small leisure craft we built with Aranet consortium with Turkish partner, and it was really demanding to find the proper cells for the electrical driven yacht. Questions: how much power can be produced from a given amount of energy? This is the problem. Here we see for the comparison the typical internal combustion engine, modern engine, of course, and gas turbine, which is even more efficient. What is the charging rate? What is the discharging rate? How fast can we put the same amount of the energy? So these are the open questions, and we have to really carefully see what do we need for the project. Again, I encourage you to find this material here. It's subsurface, actually, hybrid power options, but it may more or less is combined with also the surface power options. So what are the simplest system for the generation of well, here it's called green energy. I don't know if you agree with me. If it's really green, if we got the gensets and the diesel LNG, maybe not. But again, open question. So system topology, the quasi hybrid power plant. So we got the genset, so some kind of engine. Let's assume it's eco-friendly, so it's Euro 6 or meeting all of the MARPOL requirements. Then the generator sets the energy into the grid, and we got load. For example, we got some loads on the deck of our vessel, any kind of devices, etc. What can be added here is the AC/DC converter and the battery. Of course, with proper charger, etc. We are not addressing this. Krzysztof, key specialist in this topic, can say more, so I would not to occupy your time. But we got some power conversion, and we can store this energy. We can store this energy. It's possible to be done on nearly any vessel. So it's just adding this part. Cost is medium, but the applicability is high. So we can assume that we are sparing this green energy. Let's say green energy. Electrochemical sources. So the true hybrid, the real hybrid. So we got propulsion made from electricity. So it's made from electricity. If we combine with this, the propulsion is made here from the diesel. So it's not for propulsion, just for conserving the power to the load. And here we got the propulsion made from the electricity, from the grid. Here we got two segments of grid, we got two gensets, and we got two storages. We got two storages, of course, additionally some loads, but here the grid is combined with the electrical motor, so the genset can be driven on any level of the on a desired level of the energy production. The load can be fed, and the batteries can be loaded in the same time if there is not high demand for the electricity in the grid for the propulsion, which also can contribute to the energy saving and to the eco driving. Actually, I would call it eco driving. So a hybrid power plant retrofitting is possible and feasible. A lot of vessels actually are using this site. So if we just use this part, then a lot of vessels they are driven like this. In the first presentation, we got this topology mentioned here. So if we deal with in this way, so retrofitting is possible and feasible, but the cost is high. Cost is high. Applicability, we call it medium. Another option. So having fuel cell in line. Idea also driven from the DNVGL. So this hybrid power plant is fed again from the genset. We don't have the batteries here, but the genset is driving the electrical motor. This is additionally supported, I would say, by the fuel cell. Hybrid power technology retrofitting is demanding. It becomes demanding because of the fuel cell. But again, this part is existing. So this part can be existing, and it's met on the vessels. We got some costs at the high level. But some losses in generation can occur because we don't have the place to store it, and it's feasible for the specialized vessels like the DP operational, some standby tanks, etc. It can be feasible to have additional fuel cell in this segment. And adding fuel cell as an additional I would say segment in the grid gives more advantages. We still don't have the possibility to charge it, but we can of course combine these segments together and use only one engine for the eco driving, for example. For the eco driving, retrofitting is possible again, but very demanding. Applicability is the same, so it's medium. But there is one more segment we didn't have there. It's of course the segment where we can connect to the shore, So using this fuel cell in the grid, inline the grid, together with, of course, not in the same time, but using the power I would say power connection, of course. What's next? We got this topology for the large vessel. So for the large vessel, the electrical driven it might not be enough. So there is another large engine that drives the propeller here, but also via turbo generator, inline generator for the shaft can produce the electricity for the grid, and it's producing the electricity here combined with the fuel cells, and for the for the another loads, of course, another loads here. Fuel cells gives us the possibility of using the electrical engines here. So again, cost is really high only for the large vessels, DC grid. So here we don't have AC grid, we have DC grid for the usage. A lot of advantages. Here now, some vessels, specialized large vessels, seagoing tanks, etc., are equipped in that kind of topology, I would say. Again, inside the port, we can just switch off the engines, and we purely use the shore connection for the grid. And pure electric using fuel cells, as we discuss only fuel cells here. And for the port, we got the connection here, and for the operation, we got fuel cell going on the to the grid. Retrofitting again is possible but pretty demanding. Cost it's really high, and the applicability unfortunately is low. So it's only for the new vessels, and some ideas must be found how to define if this vessel is feasible for it or not. DC grid again gives us advantages. Okay, so the fundamentals of this DNVGL report is using some new technology. So fortunately here we are encouraged to seek for the new technology, like solid state electrolyte inside the batteries, supporting some technologies, some new materials, and reducing, for example, the friction and other things inside the power plant, and looking for the new feasible production level. Metal air technology, this is the key vector for the development for now. Of course, we all know that 25 years ago, everybody said that the CD-ROM is a key factor for the storage of the data, but now it's not. So I would say yes and no. We will see. And here, of course, the advance in the lithium-ion technology is a very important thing. Management system for the charging, etc. This is something that I would not have to tell to you because you all know it very well. Life cycle. This is something that we have to address, because now it's fine when it's new. You get a new cell phone, it's working very well, but after 2 years, it's only on 20% of its battery. So the battery life cycle is something really crucial, especially that you have to use some special technologies and materials inside, which are not, they are not. They must meet some standards for the environment as well. Okay, so we got some cases here. First of all, case for the British Columbia Electric Ferry World Leader. I called it like this. I know that the friends from Norway would be offended a bit, but I hope not too much. And British Columbia is pushing really hard, and they are willing to have 5 full electric ferries in 2020. They are operating now in the hybrid mode, but in the future they want to switch fully to electric. So it's also an option to have the levels of introduction of this technology, which is good and promising. These ferries look like here. So the hybrid system combination, now they are also interested in reduction of NOx and NOx. So they use the selective catalytic reduction. So the means we already discussed. Typical design, two propellers, special design for the reduction of underwater noise, less consumption on the deck, some LED lighting, and other. The ferries are pretty small, so something like 50 vehicles, up to 400 passengers. So they are not really huge ferries. And our friends from Norway. Leader in Europe. We have to call it like this from the early beginning. So the first battery powered ferry Ampere, driven in 2015, zero emission. They introducing new technologies. So here we got this ferry, pretty nice. It's still in operation, so it's still serving in Norway, and the biggest all electric ferry, so fully electric ferry, will be in service 2021. Basto electric, 140 meters long, 600 passengers, 200 cars, and 24 trucks. When you visited Norway, if you visited Norway, you know that this is the crucial point to avoid traveling to the west of Norway and to the north, just to avoid crossing the Oslo fjord by a car. So this short connection here avoids us this long route, avoids for the traffic. I don't have to say that for the inhabitants of Oslo, it's really important. So everybody who was driving to Stavanger or to the north of the Norway through Oslo area knows this Horten ferry. There are a lot of ferries down there, so there are a lot of ferries, lot of environmental impact. So they are trying to find this idea. So these pretty large vessels, up to 24 times per day, will cross this Oslo fjord. Nice. Stena Line hybrid. So we don't have the full power, only electrical power. But look at the size of the vessel. It's really huge vessel, and that can travel through the open sea. Up to 500 passengers, 500 cars, 2,000 meters of lanes inside. So also the trucks can be loaded here. A large vessel, and some stepping of the introducing the battery power for the improving the maneuvering capabilities, like battery power on bow thrusters, power usage for the operation, and using this for the supporting the operation. Then they found out that the operation can be done through a couple of nautical mile. 1 nautical mile is nearly 2 kilometers, so up to around 18 kilometers from the shore. It can be driven only on batteries, and full battery up to 50 nautical mile for the Baltic standard. It's really high. So the capacity of 50 megawatts hour. And the Stena Line electric, it's also the idea to order the fully electric ferry by 2025. Stena Electra by 2030. This is the first large seagoing ferry run only on the electric. Run only on the electric. Pretty large vessel, so up to 1,000 passengers. Okay, so now we got this idea for the few informations about the fuel cells. The fuel cells are in different technologies like alkaline, proton exchange, high temperature cells, and or direct methanol cells. They got different parameters that we have to share, like temperature of the operation, the power capacity that can be stored or generated inside such cell, efficiency of the electricity from such cell. What is the drawback? What is the drawbacks? And so if we got the emission of CO2 or CO or some kind of sulfur or and other things, so we have to take care of this. What are the costs, lifetimes, and size? We will not discuss every one of them, but you have a very good source here from the Mr. Singh that combined all of these factors in one publication found here in this identifier. So what are the vessels and projects that were already driven by the fuel cell? Exemplary, of course, because there are some more now. Like the AFC, so alkaline fuel cells, already found in this power of production power from the single fuel cell. Also another one, so PMFG, proton exchange fuel cells, also has been found in these vessels for the typical power. Safety of fuel cells here is a big issue, and from the beginning the fuel cells, because we get the hydrogen, highly flammable, explosive gas, we have to really deal with the safety. And for our biggest regulator, so IMO is giving the code for the dangerous goods, so carrying dangerous goods like gases, IGF, so gas fueled vessels, MARPOL, of course, and the SOLAS requires, for example, that the vessel should sustain the possibility of generating power. So if we don't have the power generator, you might skip the emergency power generator, but the SOLAS says the emergency power generator must be installed. So of course, how to deal with it? It's another regulatory problem. Class societies like codes and standards that are driven, for example, by DNVGL or any other society. And of course, last but not least, the electrical institute. So any code standards done by the electrical institutes, both local and international, must be met here. And we got this I would say a circle of safety. So many different things must be combined into one system to achieve the safety of the fuel cell. So discussing, we can think about the fuel cell versus batteries. Accus, of course, constraint of the technology and our safety issues. These are the biggest things. And I believe it's all for this presentation. So thank you very much again for your presence.
Thank you, Maciej. One question: do we have to make 5 minutes break?
For me, no.
Yeah.
If you need, it's only I have my coffee here, so.
Okay. You are a very tough man. So I have one question. You mentioned about the electricity issues. Please tell me, according to your knowledge, which solution is better about the charging the batteries for the electric ferries for electric vessels, for hybrid vessels which use batteries? Is it a cable charging, automatic cable charging is better solution, or wireless charging? As we know, that kind of solution we can find in the ferries right now in Europe. So according to your knowledge, which solution is better? Because as we know, cable solution has advantages and disadvantages, and wireless charging system as well has its own advantages and disadvantages.
Well, the question is not simple, but I will always seek for the efficiency, because if we are losing power for the wireless, we know that it's becoming more and more efficient, this induction charging. But if we are losing power down there only for the heat, then it's pointless, really pointless to go for this technology. But if the power loss is really small, and now the recent technologies in wireless charging are better and better, so the power loss is really small, but the time of the operation significantly decreases, then the wireless is a promising technology. We got this discussion in the I believe in Gdynia port, where they got the standby power socket for the ferry, so not to generate this noise I mentioned. And they said maybe wireless, but of course it's always a question, what are the efficiencies? What are the efficiencies? And also the standards here can be problematic. If we decide to one standard, for example, in the many different ports, it will be brilliant. Even if it's wireless or wired connection, it will be brilliant to have it. But if there will be 5 different standards, then we got a huge problem with the
What about the safety? Maybe safety is a clue in the watercraft technology.
Yes and no, because the advantages of the connectors, waterproof connectors for this usage, high power actually usage, this is something that is done now. Wireless, of course, has some advantages, like very fast release. So if you just stop charging, you can fastly release. You don't have to take care with the socket, with everything. But again, it can be misleading that the safety is the only issue. Of course, it is very, very important. But if it doesn't meet safety standard, we cannot discuss any kind of technology, for sure.
Okay, thank you. Does anyone from audience has a question? So please type it in chat if you have any question. And I think Maciej, we can start the last presentation. Last presentation will be scientific presentation, theoretical model calculating the resistance to motion and demand for the power of the watercraft's propulsion system. I would like to mention that Maciej is a professor of the Maritime University of Szczecin. So there is no only the technical issues, but also the scientific issues. So the last presentation will be a bit of scientific issues. So Maciej, floor is yours.
So thank you very much, and thank you very much for scaring the audience, because you probably scared them, and now there will be a big loss in our list. So hopefully not.
I think the audience maybe will be scared, maybe not. But this is also the part of the every movement, car, vehicle, watercraft, how to calculate the demand for the power for the drive. And it doesn't matter, is it a train, is it a car, is it a truck, or is it the vessel? We must calculate the power for the drive. So this is kind of answering for the question how to calculate it. So once again, Maciej, floor is yours.
Thank you very much. I hope it will not be very boring. Okay, so do we see this presentation? Is it seen clearly?
Yes, it's perfect.
Okay, very well. So thank you very much for this very kind introduction. The theoretical model, I will try not to be very theoretical. The demand for the power. So what are the main factors that are stopping us actually? So if we know what is stopping us, then we know that the demand for the power for the any kind of craft in the water. What's stopping us, what's pushing us, what type of engines, we already know it very well. What are the interconnectors with the what are the means of this push, so shaft, propeller hull, and the resistance of calculation, which will be, I promise, will be pretty neat, simple, and understandable for everybody. So how do we know what to calculate? How do we know how to assess the energy? What are the requirements for this analysis? Unfortunately, here are no simple question that okay, you just use this equation and you will have it. This is really complex thing. And now if you look at the conferences in this subject, in the shipbuilding, in the naval architects, these are really huge conferences with many articles, and many of them are touching pretty complex and very important things. I'm not saying this to say that my science is most important in the world, because it's not, but the complexity of the hydrodynamical move is something that we really see. What methods we got? First of all, we got empirical methods. So we got these methods like Holtrop-Mannen, then can deploy the ship shape inside the water and can gives us the calculation that can answer us how does this friction, how does this power loss will be. Of course, these are non-linear calculation and the changing in time and in the domain of speed of the vessel. We got this calculation like force is pressure multiplied by area, etc. Pretty complex and a lot of things going on there, but the results here in the empirical methods, they are not always very promising for more complex design. But for the simple design, when we need to just see the number, see the range of the numbers, they are enough for our work. So this is the first step. The second step is, of course, computer fluid dynamics. So CFD. The CFD is closer to reality. We call it closer to reality method, and hydrodynamic forces are simulated inside the computer. But this can be performed only in the hull modeling. So modeling the hull or the parts that are inside the water, they are in domain of time modeled in some kind of flow, linear, non-linear, turbulent, whatever. The computer itself requires a lot of computation. These are the really huge equations with a lot of variables, hundreds of variables that is influencing one to another, and this computation take a lot of time and requires very precise model of the hull and what we want to achieve. So it's not that easy that you just say, okay, compute me this hull and you will have the answers. It's not that easy. Often it does not give the direct answer. And the third one is model methods called also a real one. gives us the most accurate, most reliable for calculation of the ship resistance inside the model tank. So you've got towing tank where you just tow the model, so this reduction model of this hull. You just tow it inside the tank and measure the resistance, and then multiplying by the appropriate scaling factor, and you got the resistance of the real hull in the water. Most expensive and not always giving the immediate answer. So you have to have a few models to see how it will behave. These are the scientific methods we use. Sources of resistance in the vessel are, of course, hydrodynamic resistance. So the vessel is the only transportation that is in between two different I would say environments. First environment is, of course, water. So we got everything that is under the water is dynamically affected, but the part of the vessel is in the air, so we got aerodynamics here. So two things must be addressed. Fortunately for this aerodynamics is only the wind resistance, because the vessel is not moving really fast. Maybe the fast hovercrafts they got some issues with own induced wind field, but typical vessel going up to 20 knots, we have to only deal with the wind resistance from the generated field. But underwater, it's not becoming that easy. We got wave making resistance, we got skin friction resistance, appendage resistance, and pressure resistance. It's all of these factors must be overcome by the own velocity, by the own propulsion. Easy, simple, everybody knows it. Sorry for saying this, but I had to. Sorry. Okay, sources of resistance from this planar view. We got our hull inside the water. So if we put the hull inside the water, of course the surrounding water will have to be somehow put away. So we got this I would say empty space occupied by the hull, and it generates us the moving hull. It generates us the wave system. We call it a wave system. So first of all, if we move in this direction, we got this vector for our movement, and first of all we got the high pressure on the bow of the vessel in the front. And of course, this high pressure generates the flow through the hull. This flow through the hull is inducing waves. It's inducing waves, divergent bow waves, and stern waves. So these are the bow and the stern waves, because of the difference of pressure, the high pressure and the low pressure here on the aft of our hull. How does it look like? Of course, we all who was sailing with the even small boats saw the waves induced by vessels. So this is the induced system of the wave resistance. We got this low pressure here, high pressure here, which can be seen, and induced waves, stern and bow waves. Of course, symmetrically, if we move in the one direction. So these are the main sources of the resistance, and what can be our measure to overcome this resistance? Of course, engines, any type of engine. If it's just a typical combustion engine, if it's electrical engine, if it's hovercraft, because it doesn't have to be the engine that's working in water. It can work in air. or it can be any type of any other propulsion. For example, towing. Yeah, towing is also some kind of propulsion added externally, but the resistance is still something to overcome. What are the needs? What are the needs? Medium hovercraft, for example, is total power consumption up to 3 megawatts, but for large aircraft carrier, we have to something like 220 megawatts. Big and really demanding. Here we got some typical issues like fast ferry or a merchant container that requires from 20 to 40 megawatts of power to move for the desired speed. Ultra large tanker, far lower speed, but the propulsion is must be higher. And we got some warships. So these are the vessels. Like here, some explanation of the types is done here. So it's just a type of the vessel and examples of the vessels as well here. What is the propulsion? We can find the engines utilized. So these are the types of the vessels, types of the engines. Often really huge one. Energy efficiency. From the perspective of this total propulsion system, the input of the fuel, I would say the energy stored inside the fuel must be changed to the mechanical energy. And in the heat engines, it's of course the classical diesel or the gas oils engine. For the LNG, it's a gas engine, and for the electrical, it's of course simpler because we don't have this heat input, but we got the energy input, and then we got the conversion immediately to mechanical means. But the idea is still the same. So we got the fuel here, we got this heat input, so this fuel is changed to the heat. Then the brake power of the engine is transferred to shaft, then to propeller, then to open water, the propeller of moving propeller power, and then we got the thrust. And that push us in the direction, in the front or in the stern direction. And at the end, we got this effective towing power. So this is the production here, production of the movement. What is affecting, of course, efficiency of engine. This is something we fight really heavily to increase it, but not only. The gearbox efficiency is also crucial point. Shaft efficiency, something we cannot skip. Then we got for the movement of the propeller, rotative efficiency. So the propeller itself, it must be efficient, and we got the hull efficiency. So this when we model the size of the hull, the shape of the hull, we also have to deal with this efficiency as well. Vessel has some engines, and here we see the auxiliary engine on a gas carrier. Really huge auxiliary engine that was only driving the turbo generator. So it was only for the power production. Of power, something like 10,000 kilowatt or something, as I remember properly. So what we have to consider, the efficiency of the heat engine, and complication of system is a factor, and of course what type of power is it run on. Not only heat engines in the way of the typical gas or fuel propelled engines, but also heat engines by means of turbines, gas turbines. Here we see 2 turbines of total power, something like 30 megawatts, high pressure and low pressure system on the gas carrier. Very big compactness. So it's really small. It's a small device. It's a small device, high power, but very complicated and less efficient than the modern engines. If we look at the electrical driven motor, of course we got electrical energy or generation or storage. So the either generation or storage must be met here. Both three-phase alternating current or direct current. Also, any other ideas like BLDC or different concepts are found on different types, of course, of the vessels. And here it's simpler, but the overall is the same. Overall is the same. So only this part is different. So this engine efficiency is different. If we got gearbox, of course we have to deal with it. But the rest is pretty the same as for a couple of years ago. So we don't have these big advantages here. Shafts and gears. So we got our shaft. How big construction is it? It can be really huge construction with big bearings and very heavy construction. Here we got the dismantling of the shafts on the LNG carrier, and as you can see, it's the production of this energy here must be transferred to the propeller with really great accuracy. So these bearings here that we see, the non-linearity was something like 0.01 millimeter for the whole length of shaft, like 25 meters or something. And of course the size is important, and then the weight is important. Afterwards, if we meet the hull, the shaft must be connected with the propeller. So the type of the propeller, of course, is crucial here. Size, weight, shape, and the interaction that is done, because this interaction is also for the steering of the vessel, which also is a crucial point and have a lot of consideration for the modeling. Here we see the large propeller during the mounting into the hull, to the shaft. I'm sorry. Then it was looking like this. The precision of this shaft is really important, because we cannot have any imbalances here. The vibration can destroy the whole line, shaft and main bearing and propeller itself. Here we got the fixed blade propeller, so it's not moving. On many vessels smaller, they are moving, so they are controllable pitch propellers. For the small crafts like 60 HP, for example, here, the optimization is also crucial. Who is keen of the motor yachting knows it very well that this part is also pretty important. Now we got new trends like printing the propeller, so just changing the shapes of the blades, printing in the very hard plastics or in metal is something that is not frequent. So this optimization can be very much faster, because you just design it and print it immediately. You have the product. Before you have to make the mold, make the casting, and then you got the product after some machining. Now it's simpler and easier. Type of the propeller, I just showed one type. There are many different ones, so there are something like 10 or even more different types of the propellers. Here we got so-called azipod, so special system for the propeller combination of the rudder of the steer with the propeller. So there are mechanical connection. These two propellers are rotated contrary, so they have different plates, so they can gain really high efficiency. And for modern vessels, looking for this solution, so the more complicated but far more efficient solutions is something that must be. So seeking for the new solution is always a good idea. What about hull? What about hull? Hull and its shape, also called the block coefficient. So it's a amount of water that will be pushed away, and how square is it, the larger the coefficient will be. If it's more smooth like a container vessel, it has lower this coefficient value. Of course, the pressure multiplied by the area gives us this losses of power and consumption matter. So it all affects the consumption here of the energy. Monitoring the energy consumption is something really important. Even on a small crafts, you got some power monitor. You can install some desired level of power that must be transferred to the system. What is the power, what is the fuel consumption, what is the energy consumption, etc. These are all of the factors that must be addressed. Also, if you got the hydrogen packs, you need to control the temperature. For example, these hydrogen packs, how do they behave in different temperatures? These are the things that modern automation can answer. And here we got some solutions from the LNG vessel, large LNG carrier, to boilers, really big one, to turbines, monitoring of shaft temperatures of bearing, etc. Vibration, you got here vibration 0.06, as I can see, level of vibration for the shaft. It's also measured, got some monitoring, triggering system, etc. And you can control and command it. So it's also important. Very much here. Common platforms, so you can have the platforms for many different systems, and you can transfer it to the different points of vessel, or just to have the proper monitoring level for any kind of mismatches that can be done here. So it's also I would say a challenge for you as an ELMAR consortium, and for you as a future naval architect. It's a challenge to build better systems, to build more energy effective systems, better commanded systems, etc. It's a complex, very complex and complex world. Okay, unfortunately, we have to deal with this. Maybe fortunately, sorry. Of course, when you got the frictional resistance, we can have a few I would say calculations to be done here. So wetted surface, so we deal only with hydrodynamics, is a surface that is normally immersed in water, and we got two formulas that can contribute to calculation of this area from Denny and Taylor, and using appropriate numbers. So we need the length of the vessel, length overall. We need this block coefficient I mentioned. So the larger the coefficient, the more squared the hull is, looking from the planar view. From the Bayer-Crack coefficient gives us also the idea how to deal with this hull for the hull beam. So the how wide is our vessel. T is draft and displacement in tons, so how much weight is put. We got this calculation. So first of all, we calculate the coefficient of frictional resistance, and moving of vessel in water is always somehow braked. So we got the braking of this, and this friction actually depends on how much water is surrounding the hull. We understand it because we feel it, that if you go more under the water, the friction will be higher. Depends also on the roughness of the hull. So it's good idea always to have clean hull out of the fouling, and have these special pints that reduces the friction. And of course, the viscosity of water here is also another point in this coefficient of frictional resistance. Interference factor. That depends on the interference between the hull. For the single hull, you got one. For multi-hull, you got some interference. So the catamarans, etc., have to take care of this interference factor. Coefficients of residual resistance, and it's actually the component of the wetted surface in the hull. And it's usually determined by the maneuvering tests. So you got this coefficient of the residual resistance. You can assess it in the model basin, or you can use the simulation. So this residual resistance also affects the total resistance of the hull, and the density of the medium. Of course, obvious, you got different densities of the water here for the different areas. And these simple formulas and as an output, we can provide this for the Elmar consortium as some very simple calculation application that can aspect some types of catamarans, some single hull vessels, and relevant. So these calculations are pretty neat, and I believe after a few minutes of using Excel, you can calculate by your own this total hull resistance. So if you got total hull resistance in kilonewtons, then you can have the idea what is the input, what is the desired input for the power that you have to provide to your engine. And this comparison, I'm sorry for Polish language, but this comparison is done for this output as a Elmar project. So the total values of the resistance for the smaller crafts. So these are not the large crafts. I showed you the demand for the power. Here we got simpler method for the assessing the smaller crafts. So really small passenger crafts up to 600 people. So giving this for the small Baltic ferries up to 80 meters long, maybe no, up to 100 even, and for the smaller one like the passenger vessel, some ferry river ferry. patrol boat, so also the vessel, depending on the speed, you can have different ideas here. How does this total resistance is equal to in kilo so kilonewtons. So it's a very I would say handy way of first type of the calculation, how to deal with the assumed power requirements. So this is open for your consortium, so you can have your own calculation and adapt it to your own needs. Even I guess there are some other vessels also included. And so, not to getting a bit too boring for you, the discussion is of course the resistance idea, but we have to also deal with the total resistance, also aerodynamical resistance, and here the wind and weather may play a large role. May play a large role, as we all know that the largest accidents, largest catastrophes, like Estonia ferry or Jan Śniadecki ferry, they were in pretty bad weather. So the weather here is something that we must address, and we cannot skip it. The power generation also, the way how does the power is generated from the fuel or from the stored electrical energy is crucial to know. So it's a pretty complex system. And efficiency, delivered power versus output. This is our efficiency factor here. Monitoring of many different parameters with modern automation is often an answer how to deal with this parameter. And that's, I guess, all from my side. Thank you very much for your attention.
Thank you, Maciej. I know that we are 2 minutes. 2 minutes ago, we had to finish our seminar, but I would like to show you how does the model was used for the calculations. For the calculations of the power required for the drive. So Maciej explained the theoretical model calculating the movement of the resistance and hull. Do you see my presentation?
Yes, I see.
So this model was used for the calculation of the power of the drive of the ship. So this is the view of the program where the resistances of the hull was calculated. So other calculations were done for the very popular ship in Poland, especially in Mazury and Warmia and other parts of the Poland, SP-150. This is parameters of the ship. The maximum speed is at 20 km per hour, leisure speed 10-12 km per hour, 270 persons, and the engine power 140 kilowatt manufactured by Skoda. And we did estimations about the required power. Here on the figure, is presented the ship hull resistant forces dependent on speed. And here are simulation of the acceleration, deceleration of the speed, and here are calculated the power of the engine required to travel the boat with that speed. So according to the simulations, we see that acceleration to 12 km per hour required 54 kilowatt of the temporary power and 29 kilowatt of the power at constant speed 12 kilometers per hour. When we use the higher speed, so acceleration to maximum speed 20 kilometers per hour and deceleration in 3 minutes, we see that we need 184 kilowatts of temporary power, so this is the peak power, and the continuous power at constant speed 20 kilometers per hour, it is required 150 kilowatt. 15 kilowatt. When we compare it to the power of the motor, we see that the power of the motor is 140 kilowatts. So we see that this calculation are similar to the power required by ship. Additional, we proposed the hybrid propulsion system. And the battery from electric car BMW i3 with the battery capacity at the level of 21 kilowatt hour. Next, we estimate the parameters. So at the continuous power, we need at the continuous speed of 12 kilometer per hour, we need 29 kilowatts. When we take into the consideration that operational time is at 12 hours, we need 300, almost 50 kilowatts of energy, which gives us 17 pieces of batteries, and the required electric motor is 30 kilowatts. Here on the slide, there is an estimation of the fuel cell savings during the season, 5 months. It's almost 6,000 liters of biodiesel, and according to the information presented by Maciej, to the emission of the harmful substances, we can estimate the final values of harmful substances not emitted to atmosphere. So, as you see, this is a very nice way to estimate the power of the ship, especially the ships which are can use in the Baltic Sea area. So this is our proposition. So Maciej created the tool for calculation of the hull resistances. I have a model for calculation all the electric and hybrid drive parameters of the ship. So thank you for this is additional explanation. What for was this theoretical model for calculating the resistance? Now I would like to say a few words about our speaker. Maciej is a professor of Maritime University of Szczecin. Szczecin is 2-3 hours from Stralsund. So university was established 1947, offered education for 3,000 students with 12 Bachelor of Science programs, where 2 are in English, and 6 Master of Science programs, where 2 are in English. University allows to educate in Faculty of Navigation, Faculty of Marine Engineering, Faculty of Engineering and Economics of Transport, Faculty of Computer Science and Communication, and Faculty of Mechatronics and Electrical Engineering. To be honest, Maciej, I don't know which faculty you work.
Navigation.
Navigation. So number 1 first. So thank you everyone for participation in our seminar. Thank you our speaker for these presentations.
My pleasure. Purely my pleasure. So thank you very much for your attendance and that you finally get to the end with me. Sorry for this long talking, but I hope it was useful for you somehow. And I'm really glad to see that this method we contributed to were used in this brilliant Elmar project. Thank you very much.
Thank you, Maciej. Does anyone from audience has a question?
Actually, I have one question.
Okay.
So, Maciej, you've said that variable pitch propeller is becoming more popular, but as far as I know, it has a lower efficiency than constant pitch propeller. Therefore, it's not used on oceanic vessels, for example, tankers. Is that right?
Yes, exactly. I won't go back to this presentation. You have it uploaded already. As you can see, this large propeller that was mounted. I made the photos during my stay on the shipyard.
Please share the screen, Maciej. Please share the screen.
Okay. Just a second.
We don't see
Sorry.
your presentation.
Yeah, of course, sure. It's better always to show, not to talk about. Just a second. Just a second ago. Okay, so we got this fixed wing propeller for the large tanker, and it's fixed. So it's a fifth blade propeller, and actually, yes, the efficiency and the complication of the system itself is far less than variable pitch propellers. So here. This is better solution for the vessels that are doing the long voyages, or we are assuming that they will be traveling just as a transportation. But for the operation, when you need to move the vessel back and forth, when you need to control the position, like DP, so dynamic positioning. Dynamic positioning operations, you have to have the full control of the power. Here you don't have the control of the power. When it starts rotating, it's really hard to stop it. And the variable pitch propellers, they are easy to stop because you just move the pitch to 0 and it's still rotating, but it does not generating the thrust. And of course, efficiency is lower in the variable pitch propellers. Complication is far higher, so it's not for every use. You are absolutely right. For the small vessels, for the small crafts, outboard engines, here you also got the fixed propellers, fixed pitch propellers. Thank you.
Thank you for the answer.
Does anyone from the audience has a question? So, thank you for your participation in our seminar. Thank you for participation for our guests from Host University from Stralsund. Thank you for participation guests from Klaipėda University. Thank you for participation students and other persons from Gdańsk University of Technology and Maritime University of Szczecin. I hope you enjoyed, and I'm sorry for 15 minutes of student quarter extension, time extension of our seminar. I welcome to encourage you to contact with our colleague Maciej Gutzma from Szczecin. I encourage you to contact to my person, and we will answer your question in the future if you have something. So, thank you once again.